Hi, my name is Greg Greenberg with Hanna Instruments, and today I'm going to introduce the HI 3000 series professional benchtop meters. In this series, we offer the HI 3220, which is our pH millivolt meter, the HI 3221, which is our pH millivolt and ISC meter, and then finally the HI 3222, which is a 2-channel pH millivolt and ISC meter. Let me show you what's in the box when you receive any one of these meters. The meter itself, along with its calibration certificate from the factory, a probe holder, the directions, a quick reference guide if needed, 2 packages of buffer solution and cleaning solution, a temperature probe, again with its factory testing certificate, pH electrode with its factory testing certificate, the electrode instruction guides, solution to refill the electrode as required, a pipette to perform that task, and the power cord. Next, let's talk about the features of the meter. I have with me today for demonstration purposes our HI 3222, which is a pH ORP ISE meter with 2 channels and calibration check. Some major features of this meter are as follows. It has a dot matrix LCD display for ease of use, virtual keys that will change with whatever is being shown on the dot matrix display, and then an 8-button simple operation. First of all, we have the help button. So if you're working on the meter and you ever get lost with whatever screen you're in, you can simply push the help button and directions will be displayed on the LCD screen. Calibration button, that takes you right into the calibration mode. And then the range button. For example, if you're on channel 1 and you want to go back and forth between pH and millivolts, you simply hit the range button. And then when you hit the channel button and you go to channel 2 and you want to switch back and forth between ISC and millivolts, you do the same thing by pushing the range button. We have a menu button which displays information for the virtual keys, simple up and down buttons which moves you around the screen depending on what mode you're in, and then an escape button if you ever need to back out of a particular screen that you may be in. When I turn the meter around, I see the on-off switch, the connector for the power cord, the connector for the USB cord which is going to plug into a PC, and then 2 independent channels that are galvanically isolated, which means that when 2 probes are in the same solution, they won't interfere with each other. When I look at channel 1, for example, I see the input for the temperature probe, a BNC connector, which is the input for either a pH or ORP electrode, and in the case that I'm going to use a reference probe as a half cell, I simply plug it into this connector and then plug the indicating probe into this connector. Exactly the same thing for channel 2, with the exception that we're going to be working with an ion selective electrode and or an ORP probe. Now keep in mind that this is the 3222, which is a 2-channel meter. We offer our 3220 and our 3221. In the case that you're using those meters, you would only see 1 channel. When I turn the meter upside down, I'm going to see 2 holes that are used for holding the mounting bracket for the probe holder. Next, I'm going to turn the meter on and show you some advanced features. Now I'm going to flip the meter on. And as you can see, it's warming up. And once the meter warms up, the LCD is going to display a lot of different information. Now let's take a look at what we're seeing. In this case, it's telling us that we're on channel 1, automatic temperature compensation. The solution that I'm measuring has a pH of 7.03 with a temperature reading of 23.9 degrees Celsius. A really great feature with this meter is that I can actually see the condition of the probe after calibration. In this case, it's telling me that it's at 100%, and I've calibrated with buffers of 4, 7, and 10. If I want to record the current reading, I simply hit the log button. And then another feature we have is auto end. So when I push the auto end button, it tells me to wait. We see the stability indicator. And once the W disappears, AE will flash and the reading is locked in. Now this won't change regardless of the solution that I put the probe into, and this is useful with a gas sensing ISE where the readings will continually change. So I'm going to hit continue to go back into the meter mode. Next, let's hit the menu button. The virtual keys have now changed. We see the recall button, GLP, and setup. I'm going to hit the recall button and I see two different options, auto log and manual log. And since my last record was done manually, I'm going to hit the manual log and I'm going to find the log, and in this case it's log number 21, which shows the pH and the date. If I want to see even more information, I hit the more button. We see again this is record number 21. It has the date, the time, the temperature, the pH, but we also see the reading in millivolts, the offset, and the slope. Now, if you want to download this information to your PC, remember we talked about the fact that this has a USB connection port in the back, and you simply connect the meter to your PC and download the data. Let's escape out of this and take a look at GLP, which stands for Good Lab Practices. And this is information based on the last time that the probe was calibrated. So here we see the date, the time, the offset, the slope, and the buffers that were used. So we'll escape out of this and go into the setup features. Since I'm in the pH mode, let's look at its setup options. The first item we see is log interval. If I push the button, I can choose from either manual, auto end, or intervals from every 5 seconds up to 3 hours. Next is the pH resolution. I can choose from 0.1 to 0.001. Auto end stability. So if drift is not an issue, then I can choose to do it very fast, or if I need a very accurate reading, then I push the accurate button. Calibration timeout. So in this case, the meter is set to 1 day. Once 1 day hits, then the meter will tell us that it's time to calibrate our probe. First point mode. So earlier I calibrated the meter to 3 points. If I go back and calibrate one of these points, I can choose to either replace that 1 point or apply an offset to the other 2 points by pushing these buttons. Custom buffers, I can choose up to 5 custom buffers. If I want to see the calibration points or out of cal range warnings on the display, I check or uncheck these boxes. Temperature unit, I can choose between Fahrenheit and Celsius. Backlight, contrast, date and time format, all self-explanatory features along with the date format, language. If I want to hear this beep, then I can keep the box checked. If not, then I uncheck it. Instrument ID, so if you want to identify this meter with your other like meters in your lab, then you can assign this meter or your other meters a number. Baud rate, in which the meter will communicate with your computer, and then the factory meter information. Next, I'd like to show you how to calibrate it. Before we calibrate, it's very important to condition our probe first, especially if it's new. What I've done here is I've taken the liberty of putting my probe into a storage solution. And in this case, it's HI, Hanna Instruments 70300. Now, if you don't have a storage solution, it's okay to use a buffer as well, preferably number 4 as your first choice, and if you don't have a number 4, then number 7. So what I'm going to do is I'm going to wait for approximately 2 hours until my probe is conditioned. And what I've done here is I've already taken the fill cap off for demonstration purposes. So what I've done is I've unscrewed it from the probe, I've taken the cap off, and I'm going to set it aside. And the reason that I want to do that is I want to create a positive head pressure that allows for a higher flow rate through the junction, which results in a faster response time. So once I've done that and my probe is accurately conditioned, I'm going to remove the probe from the storage solution, and what I'm going to do next is I'm going to rinse the probe in deionized water to get any excess storage solution off of there. The next thing I'm going to do is I'm going to take my buffer, which in this case is number 7. And just a side note, as you can see, I put my buffer onto a magnetic stir. And it's extremely important to do this in a laboratory setting because you want to make sure that your buffer solution remains homogeneous at all times. So since I've done that, I'm going to go ahead and lower my probe into my buffer. Alright, and I'm going to start with, start by hitting the cal button. And keep in mind too, it's important to make sure that your junction is covered by the solution, otherwise the calibration is not going to work. So what I've done here is again, I pushed the cal button and I'm waiting for the meter to read at 7.01 or to recognize that buffer. And when it does, I'm going to hit the confirm button. So let's give that a second to come up. Okay, so I'm going to hit the confirm button. And what I'm going to do next is, once again, I want to rinse off my probe with deionized water, get any excess buffer off of there that's already on there. So I've done that, and since I just happen to have a 4 with me, I'm going to put 4 onto my magnetic stir, and I'm going to put my probe in there and let it calibrate. Now at this point, if I wanted to go with a 10 or a custom buffer, then I can go ahead and do that depending on what type of calibration and how many points that I want to calibrate at. Something important to note while this is doing its reading is that this meter has cal check. So if my buffer was contaminated or my probe was dirty, then the cal check feature would tell me that. So as you can see, I'm ready to confirm, and in this case, since I'm going to do just a 2-point calibration, I'm ready to take my measurement. But the next thing I'm going to do before I do that is I want to escape out of here. And as you can see here, again, this is part of the cal check feature. This tells me that my probe is at 100% and it's ready to go after calibration. Next, we are ready to take our measurement. Some final notes. It's extremely important to keep your probe conditioned after usage. In that case, I recommend using a storage solution, HI 70300. If you choose to store in the probe's protective cap, simply pour some storage solution in the cap and put it on the probe accordingly. If you don't have storage solution, again, it's okay to keep the probe in a buffer. Preference is 4. If you don't have 4, 7 is okay as well. Never keep the probe in deionized water. Another note, if your instrument ever displays clean electrode, it's an indication that you could have a dirty probe. In that case, we offer application-specific cleaning solution. Today's demonstration was on a 3222, which is a 2-channel meter, and again, it's pH, millivolt, and ISE. Today's demonstration was on setup and calibration for pH. We have a separate video for an ISE, so if you're interested in viewing the ISE portion, please watch our separate video. So I hope you enjoyed my demonstration today. If you have any questions or concerns, please contact your local Hanna office and they'll be glad to help you. Thank you very much for your time, and I hope you enjoyed the instrument. Thank you.